Okay, hello kids. I think that this is working now. So I am making this video as the first lesson of the first week of the geometry over the summer course. So if you're watching this video, it is because you're intended into taking the placement test at the beginning of August. So we already have a date for that test. I will be publishing the requirements to participate in the placement test in Schoology. Um, Sorry that I have delayed a little bit posting this video. It is because the first week of the course was also the last week of the semester. So we were finishing the semester, like grading the finals and everything. And then this course has started. So that is why it is coming a little bit late. So I truly appreciate your patience. Um, so let us start. No, this is a presentation for a geometry course, and I want to tell you that this is the best math course. This is just the best math course. So, why do I say that? Not only because I teach it, because I think that geometry is everywhere. And if it is not everywhere, it is in really cool places. For example, I don't know how you feel about like visual arts and how do you feel about like abstract arts. After the Second World War, painters started like creating this new ways of representing the world through abstract paintings. And they noticed that, for example, like Piet Mondrian or like Vasily Kandinsky or like this Russian guy who I have forgotten his name, the one who painted the red square. I don't remember. It, they acknowledge that the most abstract or basic way of seeing the world is through shapes, through geometrical shapes. So, for example, this is a gorgeous painting that Vasily Kandinsky made, in which you can appreciate how he deeply understands or deeply acknowledges the place of geometry to understand the most abstract and pure things of the world. And so, let us say that, for example, you are not very passionate about visual arts and you're passionate about architecture. So, this is a building that was created by a Mexican architect called Felix Candela. Um, and I believe that this is very interesting. And well, if you're watching this video, it is because you already have taken Algebra 1 and you already know the name of the shape. Uh, this is a parabola, no? These are all parabolas. And actually, the surface is a very cool surface called an hyperbolic paraboloid. So, um, okay, this is like a very specific example of like an ode to mathematics through architecture. But in general, if you're thinking into an architectural path, then you should recognize that geometry is very deep established into the architecture. Um, okay, so maybe you don't like architecture and you don't like visual arts, but well, maybe something that you do like is philosophy, no? Like you like how people think and the history of ideas. Um, so the things that we will be studying right now, geometry, this this has a very beautiful history because the things that we will be studying are things that have been studying by humans since 2000 years ago. So, for example, the things that we will be studying right now were written in a book by a guy named Euclid more than 2,500 years ago. But the most amazing part is that Euclid was not the author of all of those ideas. Actually, he gathered those ideas from the Arabic world. So the things that we will be studying are things that have I don't know, amazed humanity through millennia, and that has amazed humanity through like different countries and different places. I don't know. I just strongly believe that studying math is one of those things that makes us the most human. Like it's something that we share among all humans. And And by studying this course, by taking this course, we will be part of that tradition of loving knowledge, that tradition, that philosophical tradition. We will study logic. So we will, I strongly believe that your way of thinking will change after this course. Okay, okay, so you don't like visual arts, you don't like architecture, you're not very in love of knowledge, you are not amazed or very interested in the history of ideas. Well, maybe you like Pixar movies. So the way in animation works, the way in which like all these characters are created, they you need to have a deeply understanding of geometry, and that is like the cool thing about geometry. Geometry is like the math that involves visual um, shapes, the things that you can see. Our mathematical objects are shapes, so that is why it is super cool. Well, I hope that it convinced you to stay through the whole course. This is going to be a hard trip, I need to tell you that. I think that right now geometry is one of our hardest subjects in mathematics, so good luck. Let us begin. So this first lesson is just about okay, so if you are in a normal in the normal course, so right now that I am recording this, the first week has already happened. uh, and the kids that are taking the course in person has already taken 5 lessons and have already presented the first summative. Every single day I am assigning a delta math for you to complete. I will be sharing in Schoology the delta math so that you can also complete it. And well, the in-person kids have a final exam and 5 summatives. You will only have a placement test. Maybe I can say it right now. The requirements for the placement test are that you'll have an 85% in Algebra 1, and that you'll also have an 85% in the placement test. So remember, maybe I have said this many times. The placement test won't give you credits in your GPI. It will only allow you to go into Algebra 2 next year. And well, that is also something very cool, because if you want to go into Algebra 2 as 10th graders, then, for example, if you're going into an IB course, you will arrive more prepared. Or if you don't want to take an IB course, well, that opens you the opportunity to take many AP math classes. You can take AP Stats, you can take AP Calc, you can go into Algebra 2 honors. There are like, it opens many possibilities. So it is a thing that it's also worth doing, but it's gonna be hard. Uh, I don't want to lie to you. This is gonna be hard. Okay, so the first lesson. In the first lesson, we just work around vocabulary. So we went over some definitions very quickly. This is a starter. This is a nice starter that you should be able to complete in 7 minutes. And I'm going to tell you something. In the in-person class, they took around 5 minutes. So I would suggest you to complete it. I'm going to solve it. So if you want to solve it by yourself, pause the video now. Thank you for pausing it. So, for example, for this exercise, you need to set up an equation to find this measurement. You need to do an easy equation: 12 plus 7 plus this thing that it's called x equals to 24. So you collect like terms. 19 plus x equals to 24. So x, you subtract 19 in both sides, x equals 5. Easy dubs. Now, for example, you need to draw the things. That will be the secret of this course. Try to make a drawing. Try to picture it. So here, angle STU measures. You need to find the measurement of angle STU. If you know that STL, o sea, this angle measures 76, and angle LTU, o sea, this one measures 85. So angle STU measures 76 plus 85, and I won't do this math, but you can do it. I will go to the next exercise. So which one is the vertex? Which ones are the sides? So the vertex is this one. So I have two possibilities. It's either this one or this one. Now, which ones are the rays? The rays are BC and AC. So I have AC and B I AB and BC. Sorry, oopsie. Oops. This is the correct answer. He he he. Thank you. Okay. Now, um, so the ticks. What does the tick means? That this ticks means that these two sides are congruent. So that means that this side UB is congruent to side UW, and that is exactly what they are asking us here. So this one is true. So the information here, it's actually represented in the diagram. Now, what does this symbol mean? This symbol means perpendicularity. Okay, that means 90-degree angles. And in a diagram, you can think of that, you can observe that with this specific mark. Okay, so now my question is CE perpendicular to BC? So CE, line segment CE, is it perpendicular to segment BC? No, this is false. But one segment that is perpendicular, for example, FD is perpendicular to DE, because here you have a 90-degree angle. So you need to have it in your diagram. But for example, I know that this green mark exists because if I have a 90-degree angle on one side, because angles add up to 180, the other one is also a 90-degree angle. Okay, nice, easy. So this is an opportunity for you to copy. If you are taking a video right now, you're posting it, you're writing it down. A point. I'm not going to say the definition. You're going to write it in your own words because I think that is the best way of defining things. A point is the most basic unit in geometry. I remember a thing that my geometry teacher in high school told me that kind of traumatized me. He told me a point is a point. Point. In Spanish, it sounds like a little better. So a point is a point. It is dimensionless. It has no length. It has no width. It has no dimension. It is of dimension 0. It's just like a tiny bit of space, a pixel, if you want to think about units in a display. Okay, what is a point? We use capital letters to name points. So a line is what you obtain when you connect 2 points. 2 points is like the space between 2 points. But it's not only this space, it's also the space that continues and continues. A line is infinite, endless, and you can extend it as much as you can, as much as you want. Always that you have 2 points in space, there is always a line that connects them. That doesn't happen, for example, if you have 3 points. If you have 3 points, these 3 points are not necessarily over the same line. But 3 points are always over the same plane. A plane is like a sheet of paper. And how do you name a plane? With 3 points. So for example, in your delta math, if I am putting a point D here, you may want to name this plane. This plane is called ABCD. But it is enough to name a plane with 3 points. Take a note on that. So collinear points are points that belong to the same line. And coplanar points are points that belong to the same plane. And think about it. So for example, in this case, I have 4 points that are collinear. But they don't need to be collinear. No, you can have 4 points and there is no line that passes through the 4. And now here you have a here's plane n. But if you have 4 points, 4 points also not necessarily need to be coplanar, no? Um, like you can also always have a fourth point outside of a plane, and that is interesting. Think about it. Um, okay, so this is something that you need to take a note on, and that it is important. So a segment, a ray, and a line are different. Uh, for a segment, the segment is just the finite distance in between 2 points. So a segment has two endpoints. A ray has one endpoint and a direction. A, and a line has no endpoints. So that is why we write them with different letters. So a segment, we write it with a little line in the top. A ray, we write it with a direction like ray AB. And this means that point A is the endpoint. Now, you can also have ray BA. Ray BA would be like this. So the endpoint would be B. And that means that these two rays are opposite, no? So AB and BA. You can also write it AB with the line like this. These are the same. They are opposite rays. And when you have a line is written with two arrows like this, no? That goes into the two directions. Awesome, possum. So a segment length is the measurement of this distance, and we say that two segments are congruent if they have the same measurement. So congruent, for us, congruent means that they are the same shape, they have the same size, they have the same arrangement. So in segments, they have the same lengths. So they have the same length, but some things can be different. For example, they can be rotated, they can be in different positions, they can be in different places in space, but they have the same length. That is what it means that two segments are congruent. We will study what is the meaning of congruent, like triangles, quadrilaterals, other shapes, but segments are like the most, like the easiest shapes to determine when they are congruent, just when their measurements are congruent. The same things with an angle. So in an angle, this one is the vertex, and these two things are the rays. Okay, now this one is an exercise for you to measure some angles. So for example, angle, so this is an observation that a student in the in-person class made me notice. So when I have the measurement of an angle, maybe I can write it here. I'm gonna erase this. You already took note of it. So I'm gonna write this angle as angle AOB. And the letter in the center, that is the vertex. That is angle AOB. And that is the same as angle BOA. You can go BOA. So that is how you write them. If you go into this exercise, what is the measurement of angle YOC? So you go YOC. And now that is a distance of from 0 to 140. I would say 140. Then what is the measurement of WOC? So from 0 to 45. No, because I am measuring here the 45 here. Then W, sorry, Y, O, W. Okay, for this one, I need to do a subtraction because I am counting since 45. Here is my 45, and I am going from 45 to, I would say, 145. So 145 minus 45, this is one that I can do mentally. That is 100. Nice. Okay, acute angle. You remember acute angle is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is more than 90 degrees, and a straight angle is exactly 180 degrees. And you can think of examples here. So, for example, I don't know, like an obtuse angle can be a YOC or YOW. An acute angle can be YOC, WOC, sorry. A right angle can be BOC, and it can also be BOX, and it can also be, I believe, just those two. Sorry. COB, no, but it's the same, XOB. And a straight angle, XOC, COX. No, those are my acute right obtuse straight angles. More definitions. This is all about definitions. So, two segments are congruent. This is repeated in your packet. Sorry, and there was a typo. There was a typo in the packet in length. Fix it, please. If you find it, that's a moral extra credit, meaning that it's just an extra credit for you morally. Okay, so two segments are congruent when they have the same length. And we use, as we have done, no, AB congruent to CD, and we use this to, this is our symbol for congruency. So the midpoint of a segment, if I have segment AB, you write it with your own words. I want you to write it with your own words. If you have segment AB, the midpoint C makes what? What is the property for midpoint C? Well, it is that it is exactly at half. That AC is congruent to CB. Know that those two parts measure the same. If two angles, for example, angle AOB and angle DEG, they are congruent if they have the same measurement. So whenever I write something like this is the measurement. No, how many degrees that you can find in an angle, no? So as we did with segments, two angles are congruent if they have the same amount of degrees. Now, two angles, if I'm going too fast, stop the video. Two angles are adjacent if they are like this. So here you have an angle, and here you have an angle, and they are adjacent. They share a ray. So, for example, this is angle AOB, and angle BOC. So two angles that are adjacent, they don't have to have the same measurement. So this one can be different to this one. That is why I am using different ticks. And an angle bisector is an angle that cuts in half another angle. No, it's a ray that cuts in half. So for example, if I have, here I have my angle AOB, and now I have this ray OC. This ray is cutting in half this angle. So these two angles are congruent. Angle AOC is congruent to angle COB. Okay, here are two very important things that you need to know, and you need to know their name. The segment addition postulate and the angle addition postulate. So, what is the word that is popping from this? The word postulate. What is a postulate? What does that mean? Okay, a postulate is a truth that everybody acknowledges. It is an evident truth. It is a evident truth. Um, the 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 truthness, no, the of this argument relies on itself. No, it is self-evident, and nobody can deny it. It is like an axiom. That is how Euclid, no, talked about postulates. So the segment addition is the one that you use in the starter of this class. If you have a line and 3 points that are over this line, the whole distance is the first distance plus the second distance. And the same for angle addition. So the whole measurement of the angle is exactly the measurement of the first angle and this measurement of the second angle. No, that will give you the whole angle. Okay, and to finish this lecture, what can you conclude about the diagram? For example, AB is congruent to BC. And that means that B is midpoint of AC. You can also see that angle A angle ABD is congruent to angle DBE. That means that the ray BD is a bisector of angle ABE. You can also conclude that CV is perpendicular to BE because of the symbol, no? That is the definition of perpendicularity. And you can come across like more sophisticated conclusions. For example, you can also argue that ABD plus DBE equals to 90 degrees. Because if this measures 90 degrees, then this measures 90 degrees. Then, if this is an angle bisector, you know that this measures 45 degrees and that this measures 45 degrees. And that is why this is a beautiful course. Okay, so I'm just going to go over the exercise like very... I'm going to upload the solutions, but I'm going to go like very... like, I don't know, like in a hand-waving way. So, for example, you need to ask yourself, like, okay, let us go for the odd ones, no? So, these two exercises are true or false. So, does line X... Look, this is a pretty drawing because you have a plane and you have a line that does not belong to the plane. So, this line does not belong to the plane, but it intersects it. Intersects mean that they touch each other, that they share something. So this line share this point with the plane. So this is true. Plane M intersects XY in more than one point. What do you think? What do you think? What do you think? It's false. T, because this line only touches this point, no? TOR are collinear. TOR TOR are not collinear because they do not belong to the same line. X O Y are collinear. Yes, they are. They belong to the same line. ROS are coplanar, and that is true because here you have ROS over the same plane. RST are coplanar. RST are coplanar, and that is true because they are all in the same plane. RXOY are coplanar. Kids, that can be true, but we don't have enough information to determine that it is true. Uh, so it could be true because RST X, no, they are not coplanar. Sorry, I made that dramatic pause without intended. No, it is there. This is clearly false. I thought that it was asking about RSXY, and here I have like a plane that passes through ROSXY, but no, RXOY, RXOY. So no, then it is false. It is false because sorry, we don't have enough information to conclude it. Like we can eyeball, like there exists a plane that passes through RXOY, but we don't have enough. This drawing, with just the information from this diagram, we cannot conclude it. So even though that it looks like it is true, this is not drawn accurately. So we cannot conclude it. Does the plane have edges? This one does, no? But remember that a plane can be extended into all sides, no? Can a given point be in two lines? A given point, if you are given a point, can this point belong to two lines? And yes, of course it can, no? Because it can belong to this arc, to this line, and it can also belong to this line, and to this line, and to this line, like all the lines that passes through this point. So yes, a point can belong into more than one line. Now, can a line belong into two planes? And the answer is yes. And to think about this, try to draw um, or to think about. So, for example, here you have a plane, no? And if you have another plane, if you have another plane, uh, imagine how they intersect. Let me make a better drawing. Sorry. Uh, you have a plane, and here you have another plane, and think of their intersections. So in this case, imagine like, sorry, o sea, I am being too perfectionist in this, and it's horrible. So how does the two planes cut each other? They cut in a line. This line is a shared line. So a line can be in two planes, and a line can be in infinite planes, no? Okay, so again, based on the diagram, only in the diagram. So, sorry, here I was missing. That is why you're watching the video. So here they are telling you I missed a thing. Here I should have a M is midpoint of HL. So you need this hypothesis, you need that statement to solve this exercise. Okay, let's try to solve it. LM is the same as MH, true, because it is a midpoint. MT bisects LH, that is true. MT bisects LH, that is true because that is the definition of bisector. MT, M, I, MT and TM are opposite rays? Yes, that is true, because they go into different directions. LH, the line, is the same as HL, the segment, false. And that is because here you have a line and here you have a segment. KT, the line is the same as KM, the line. That is true, because they are both lines, they are all the same line. KHM plus ML is the same as HL. Yes, because they are collinear points, and that is the segment addition postulate. T is between H and M. T is between H and M. That is false. Km should be equal to mt. That is false, because maybe, even though that it looks like it is not drawn accurately. So we cannot conclude it if we don't have it in the diagram. So the only thing that we know is that hm and ml are the same, but we don't know that km and mt are the same. KT is bisector of LH. That line, that is true, because where it cuts it in half. KT is the same as Km. KT, the ray, is the same as Km, the ray. Yeah, both of them are this exactly same ray, no? Because the second point only gives you like the direction. So this is true. Me salté uno. I skipped this one. MT and MK are opposite rays. That is true. You can see the drawing. KT is the same as Km. No, that is false. TM plus MH is the same as TH. That is false, because you want to use, that is like an addition segment postulate, but the points are not in the same line. The points are not collinear, so the answer is no. M is between K and T. That is right. Awesome. Okay, so these ones are super cool exercises. I would invite you truly to do them. And they are kind of hard. The first one is the easiest one, so I'm not going to do it. No. I should do it. I'm going to do it. Okay, I'm going to do it. So the first one, again, as in the starter, you set an equation adding the three segments. So you add this segment plus this segment plus this segment, and that is the same as this segment. So let us solve it. You need to set up an equation that is 27x plus 17 plus 15 plus 17x plus 2 equals to 58x minus 8. Now, collect like terms in each side of the equation. 27x plus 17x, that gives you, if I commit a mistake, I am truly sorry. I am truly sorry. Then 17 plus 15 plus 2, I believe that is 36. Ay. O sea, if I commit a mistake, sorry. A ver, let me just double check my numbers. No, I committed a mistake. Look. 17 plus 17. A ver, no. 27 plus 17, that is 20 plus 10, 30. 7 plus 7, 14. So that is 44x. That is 44x. And then 17 plus 15, that is like 15 plus 15 plus 2. That is 32 plus 2, 34. That is 34. Kids, I am sorry. Okay, I am sorry. Okay. Then we subtract in both sides of the equation 34. Or maybe you want to do something better and you want to add 8. So you get 44x plus 42 equals to 58x. And then maybe you want to subtract the 44x. And that will give you 42 equals to, what is it, 14x? And I think that that is 3 to divide by 14 in both sides, and x is equal to 3. But that is not what I am asking you in this question. I am asking you to find fg. So you need to do 27. So you need to do 27 times 3 plus 17. And this one I am not doing it, sorry. Do it and good luck. Now, this one, the next one, it is not as easy as the past one. Because observe that here, if I add the 3 numbers, if I just do, okay, this plus this, I won't get a, sorry, if I do this plus this, that is not equal to this, because I am adding this segment twice. So there are many ways of solving this exercise. One could be, for example, if you add this segment minus this segment, so I am subtracting, and from that subtraction, I can get this segment. And then that segment plus this segment is the same as this segment. Okay, I'm gonna say it again, but slowly. One way of doing this is first getting the measurement of segment DC. If you get the measurement of segment DC, then you can use it to find x, because FD plus DC equals to 112. So the first step is finding DC. And how do we find DC? Well, DC is EC minus ED. So that is the first thing that we do. Okay, I'm going to put it here in a very small way. So first, find DC. By doing DC is the same as EC, the whole segment, minus DC, minus EC. EC minus ED, sorry. Aha, I am saying EC minus ED. No, that would only give you DC. Sorry. Okay. Now, let us plug in the values of each segment. So DC equals to EC, that is 3x plus 28, minus ED, and ED measure 11x minus 229. And kids, stop for a second. Stop for a second, because here you have a common, here I am spotting a common misconception. Most of you are just going to do 11x minus 11x minus 229. And kids, that is wrong. You need to distribute that negative sign, because you are subtracting by the whole ED. You need to distribute this minus in both terms. So I'm going to write the next step. DC is 3x plus 28 minus 11x plus 229. Because this minus is hitting this, that it's positive, so now it becomes negative. And this minus, it is hitting this, and because this is negative, now it becomes positive. So be careful. I know many of you will commit this mistake, and it's okay to commit it. Learn from it. So DC, like DC Comics, collect like terms, it is negative 8x plus um, I should be able to do this mentally, sorry. 28 plus 229, 257. Okay, now that you have this C, let us go for the next step that I'm gonna put somewhere here, maybe. Um, so FE, no, FD plus DC, now we're gonna find X equals to FC. So FD measures X plus 30. So X plus 30 plus minus 8X plus 257 equals to 112. And now observe that here you don't have to FOIL you don't have to distribute a negative sign. No, because this is a positive, so this will remain negative and this will remain positive. So in this case, you don't have to distribute the negative. So you can collect like terms in a normal fashion. So this will give you negative 7x plus 287 equals to 1112. 1112 minus 287 is so negative 7x equals to negative 175. And that divided by 7 is by negative 7 is 25. Okay, but again, I am not asking you for x. That is just an intermediate step. The final step is to find EC. So EC is plugging in here 3 plus 25 plus 28. And this is the value of EC. Okay, this was hard. Don't you think it was hard? Okay, do you want us to do together DE and SQ? And I am just talking to myself here. I'm gonna do it. Okay, so this one is an easy one. No, this one I'm not gonna do it. This one is an easy one. I can help you like plugging in things, but it is the same as in exercise one. In exercise one, you just need to add BC plus CD plus DE, and that's equals to BE. So that is 89 minus 785 plus 9x plus 11x minus 1009 equals to 11x minus 823. Collect like terms. Okay, look, we can do it. We can do it. Sorry, we can do it. I'm sorry. I'm sorry. Okay. So 9x plus 11x, that will give you 20x. And then if you do 89 minus this, I believe that that is minus 705, and that is equal to 11x minus 823. So 20x plus 11x, sorry. I need to subtract the 11x, so that is 9x. I am subtracting the 11x, and then I am adding this and this. So a plus, so that is minus 882, and that divided by 9 is negative 98. And now this x can be negative because when you plug it in, the results well, I think that it is negative. No, is it? Am I committing a mistake? I am missing you kids so much because I am talking to myself. Okay, if there is a mistake, sorry. No, no, no. I mean, let us check. Let us check. 89 minus 785. 89. You can skip this, no? 9x plus 11x minus this equals to 11x minus 823. Okay. Then I collect this, and that gives me this. Why do I put so big numbers here? 785 minus 1009. So this is correct. And then if I do 8 minus 823 plus 1705, meaning that is my mistake. Thank you. Thank you. That is a positive number. It's a positive number. Look, I can send a reaction if I do this. That is something that you cannot have in-person classes. Okay, this one is hard. This one is hard. So, what is like the strategy that you need to follow? Again, you need to find a segment that you don't have, and then set it equal to the whole thing. So, for example, here I can see that I have TR. I have TR. So if I were to find RQ, then I can make it equal TR plus RQ, and that would be equal to TQ. So my strategy would be to find first RQ because I want to have the whole line. Okay, another way of getting this could be getting TS. Getting TS and then add TS plus SQ and then set it equal to TQ. But I don't like that. I don't like that because that is because we don't have like because how do we get TS? We get TS. If you try it, I would invite you to try it so that you fail. How do you get TS? TS is equal to TQ minus SQ. Okay, and that would give you like that would give you this measurement. But then how do you find X? Well, you plug in TS plus SQ equal to TS equal to TQ. And I don't know if you see, but there is like not enough information. There is like a logic mistake in here. If you try to do it, you won't get the answer because you're not using this information at all. Uh, the strategy of doing first RQ, it is because you do SQ to get RQ, you use SQ minus SR, and that will give you RQ. This is easy, no? Because actually I can spot it if I were just better at my mental maths. In my normal life, I promise that I am better in my mental maths. Like remember that this is geometry over the summer, so like I don't know why I'm the math machine that I am normally. 289, no? The math machine gun. So I can spot immediately that this is 4x plus 289 because that is SQ minus SR, no? So I know immediately that RQ is this. And now that I have that RQ is this, it is 4x plus 289. And now I know that this is the same as this. So we can set up an easy, nice equation. 290 plus 3x plus 4x plus 292 plus 289. No need of distributing a minus. No need of doing something hard. That is equal to 3x plus 343. Okay, now let us collect like terms. So 3x plus 4x, that is 7x. And 290 plus 289, okay, I'm gonna continue here. Then you subtract, um, the 3x, so you get 4x equals 2, and you do 343 minus 579, and that is negative 236. So x is equal to that divided by 4, and that is negative 59. Okay, in this case, x can be negative. And why can it be negative? Because if you plug it into any of these segments, you will get a positive value. Uh, 4 times 59, 4 times negative 59 will give you negative 36, and that is smaller than 289. So every segment will be positive. That is why x can be negative. What you cannot have are negative distances, but you can have negative x's, like in real life. Okay, this is an angle addition. This is an angle addition problem. So you can set up an easy equation. An easy equation for this. So they are telling you that BCW is 23x plus 10. A ver, I am drawing this ugly. 23x plus 10. That is BCW. WCD, that is 32. And they are telling you that BCD is 29x plus 6. Okay, so here you can set up an equation. 32 plus 23x plus 10 equals to 29x plus 6. So from here you have that 23x plus 42 equals to 29x plus 6. So now you can like, don't put the x's always in this side of the equation. You can subtract 23x, and subtract 6 and subtract 6. So you get a 38. I hope that I am right. I am not right. 36 equals to 6x, so x equals to 6. And now to find BCD is just plugging in 29 times 6 plus 6. And that is 30 times 6. I don't know how much is 30 times 6, but that is an easier operations, and you can do it mentally, because 3 times 6, 18, that is 180. Wow, wow, wow. Mental maths. Okay. SRQ. That is 24x minus 4. SRQ. The whole angle is 24x minus 4. MRQ is minus 5 plus 11x. SRM is 79. Okay, first set an equation to find x. That would be 79 plus minus 5 plus 11x equals to 24x minus 4. Okay, that is 11x plus 74 equals to 11x plus 74 equals to 24x minus 4. Okay, so again, I'm going to subtract 11 and add 4, so that is 78 equals to 13x. And if you divide by 13 in both sides, x equals to 6. Okay, and now they are asking you for SRQ, and that you should do 24 times 6 minus 4. Okay, mental maths, mental maths. 20 times 6. 20 times 6, that is 2 times 6. 2 times 6, 12. So 20 times 6 is 120. And 6 times 4, that is 24. So 120 plus 24, that is 144. Minus 4, 240. Um, okay, mental maths. Having fun while talking to myself. I hope that somebody is watching this video. Uh, WEF, you want to find WEF if DEW is 107x minus 1, DEF, the whole angle, is 178, and 73x minus 1 is WEF, no? So 73x minus 1. So again, you do 107x minus 1 plus 73x minus 1 equals to 178. This is going to be easier than the last ones. So that is 180x minus 2 equals to 178. 180x. So x is equal to 1. So WEF is 107 times 1 minus 1, 106. Beautiful, beautiful, beautiful. Now I love when questions are so easy. LMN measures 123. BMN measures 2x plus 7. And LMB measures 8x plus 16. So we do 8x plus 16 plus 2x plus 7 equals to 123. This is also going to be very easy because you do 10x plus 23 equals to 123. So just subtract 23 in both sides. So 10x is 100. So x is 10. Then they are asking you for LMB. LMB. So you do 8 times x plus 16. 80 plus 16, 96. Nice. Okay. Okay. You have arrived to the last exercise. Thank you for being here. What can we conclude? So you have this diagram. And from this diagram, uh, you have a list of options. So for example, here I have a list of information. My question is, from this option, every statement is true. Is every statement true? For example, angle RWS is the same as BWU. RWS is the same as BWU. And because these two angles have two ticks, then this is true. Now, TWS is the same as UWT. And because these two angles have three ticks, that means that these two angles are the same. So true. Now, RK is the same as BL. And because this segment has this tick, this is true. UT is the same as TS. UT is the same as TS. Okay, because you have these two ticks, that means that it is true. And now, just an interesting observation. This segment is not the same as this segment. They have different amount of ticks, so they are different. So the first option is the one that is correct. Okay, what does this symbol mean? I am expecting an answer, but I have no one with me. That means that they are parallel. HF parallel to ED means parallel. It means that they don't touch. that even if they are that they have the same slope, no? So uh, uh, this drawing, this is an easy observe. Okay, take a second to solve this problem. Pause the video. Okay, this problem is very easy because actually I have no lines that are parallel. None of my lines are parallel. So that is why this option cannot be true, because this is HF and ED are not parallel. HF and ED are not parallel. HF and are not parallel. That is why, without even reading what this option says, I know that it is true. And that is a nice strategy for your SATs and for your general exams, no, in multiple choice questions. Okay, kids, that was our first lesson. I hope that you like it. I hope that you learned a lot. If you want to ask me something, please send me an email. Next class we will be doing constructions, and it's gonna be super fun.